Okay, guys, here's our next lecture. We're going to talk about chapters 7 and 8, which have to do with ionic bonding, metallic bonding, and covalent bonding. And so we're going to start with the simple ones, and the simple ones are ions. And we've already talked about ions to some degree, where we have atoms that try to share the same electron configuration as a noble gas. And to do that, they will either gain or lose some of their valence electrons in order to achieve the same sort of electron configuration as something in group 8A or in group 18. So, section 7.1 is actually mostly a review of concepts we've learned earlier. Our valence electrons, those are the ones in the outermost electron shell, or in the highest occupied energy level of an element's atoms. Okay, now these tend to be the ones in the s and p orbitals. Okay, and these are the ones that determine the chemical properties of the element. Okay, so let's talk about this for a second. The valence electrons are the ones that are in their highest occupied energy level of an element's atoms. They determine the chemical properties of the element. Okay, and then to find the number of valence electrons in a group, okay, of a representative element, in other words, the group A elements, you can simply look at the group number up at the top. So if we take a look at our periodic table, and we see which elements are our elements. This one, 1A, 2A, 3A, 4A, 5A, 6A, 7A. Now that box shouldn't be there. Clear that. 7A and 8A. And so as we go through the alkalis and the alkaline earth metals and the borons and the carbons and the nitrogens and oxygens and halogens and the noble gases, you look up here at the top and you see that there is a 1A. Right? Those tell you the number of valence electrons. You can also do with the 1, 2, 13, 14, 15, 16, because you notice that 5A is also group 15, 6A is group 16, and so on. Okay. The other way of doing it is counting the number of S and P electrons that are available to the representative element, because that also tells you what the valence electrons are. All right, so for an example, boron is in group 3A. It has, you guessed it, 3 valence electrons. Okay? Oxygen is in group 6A, and it has 6 valence electrons. Okay? The electron dot structures of these diagrams show the valence electrons of an element as dots around the chemical symbol. The 4 sides to the element symbol represent the 4 valence orbitals, okay, also known as the s and p sublevels. The first 2 electrons should be drawn together when we fill these things, because they fill the s orbital before you move to another side. It doesn't matter which side you start with, but as long as you fill the first 2 together, and then you start alternating the other sides, just like you do arrows. And it represents this. Let's say we're going to do fluorine here. Okay, so fluorine is going to have an S and then 3 P's, right? Well, and it's going to have 9 electrons, but it's got the 1s2, which we don't have to worry about. It's got 2 electrons in its 2s2 orbital. And then as we fill out the P's, we do our up electrons. And then we come back and we finish with our down electrons. And we know that fluorine has 7 valence electrons. And so that's, that we recognize that that's going to be fluorine. It's going to be 2s2 and 2p5. Okay. So table 7.1, which I'm going to show you here, okay, is example of what all of the dots look like. So we're going to throw this out here. And here's the electron dot structure for some of the group A elements. Now, here's the problem. Please notice how, let's expand this here. See how beryllium has 2 electrons and they're separated from each other. Magnesium, 2 and they're separated from each other. All these guys have them all gathered around. This is really technically not correct. And so what these should be, this beryllium right here, really should be a Be with 2 electrons together. Boron should be 2 with a single electron somewhere. Carbon should be 2 electrons. Remember, it doesn't matter where they are as long as the first 2 are together. 2 electrons and 2 other dots with it, and so on. So as long as you do the first 2, you are okay. All right, so that's the table 7.1. So what I want you guys to do is to look at table 7.1 and there we go. Look at table 7.1 and come up with the electron dot structures for sodium. So we'll do the first one. Sodium is in the first, it's an alkali metal. So we're going to write the symbol for sodium. And it's going to have 1 electron. That wasn't so hard. Magnesium then is going to have Mg, capital M, lowercase g, and it is an alkaline earth metal, so it's going to have 2 electrons. Well, those are going to look like that. Oxygen has 6 electrons, so it's going to be capital O with 2 electrons together, and then the other 6. 1, 2, 3, so then the other 4. Total of 6 electrons. Krypton, being a noble gas, has all 8 electrons. They can fit in the s&p orbital. 1, 2, 3, 4, 5, 6, 7, 8. And that's what krypton's going to look like. Okay? Now, what krypton obeys is called the octet rule. Atoms tend to gain, lose, or share electrons in order to acquire a full set of valence electrons during ionization, or during chemical bonding. Mind you, if they have a full set of valence electrons, they begin to look like that guy, which is a noble gas, and so they achieve a noble gas style configuration. Nonmetals will gain the electrons to form negative ions, also known as, what are negative ions called? Negative ions are called anions when they react with metals, or they share electrons when reacted with they share electrons when reacted with nonmetals. That is called a covalent bond. That is called a covalent bond, and we'll get to that when we start chapter 8. Now, why do nonmetals gain electrons? Because they have high ionization energies, and they usually have high electron affinity, except for noble gases. Electron affinity is very similar to, this idea is similar to electronegativity, except electronegativity has to do with bonding with other atoms. And electron affinity is just how much it likes to attract atoms when they are not bonding. Okay, I realized once we finished the last video that we had not done the key thing that I wanted to do, starting with my new videos. And I want you guys to start, we're going to do the key questions. So the first key question for this is, how can we determine the number of valence electrons in an atom of a representative element? And that was back here in the notes, and you should be able to find it somewhere in there. That would be the first key question. Then, as we scroll down to lower in our lecture, we also have the atoms of which elements then tend to gain electrons, and atoms of which elements tend to lose electrons. Well, we're going to find those with the next few questions. In fact, the next couple of questions are all in this region here. So the first one's going to be this 4A1 and so on. And the next, you'll find the answer to the second question right here. But also, how do cations form and how do anions form? Those also come from this same region. Now, once we've finished this and we've finished 6.1, we are going to go to our section 7.1 quiz right now. Okay, and the first question is, how many valence electrons are there in an atom of oxygen? Wait for a minute. So what did you find? How many valence electrons are there in an atom of oxygen? Well, because oxygen is in group 6A, or written as VIA, then there would be 6 valence electrons in an atom of oxygen. Okay, so that's the first one. Next question. Next question is this. An atom that tend to gain a noble gas configuration by losing valence electrons are metals, nonmetals, noble gases, or representative elements. And the correct answer for this one, if they're going to lose valence electrons, that means they're going to gain a positive charge. And that means metals are the ones that gain a positive charge. So that's going to be the right answer there. Okay, pause and next question. And here's our next question. When a magnesium atom forms a cation, it does so by losing 2 electrons, gaining 2 electrons, losing 1 electron, gaining 1 electron. So pause the video, figure out the answer, and come back, and we'll give you the answer. And we're back. When does a magnesium form? When a magnesium atom forms a cation, it does so by, well, if it's a cation, that means it's positive. So, just jumped right there. So we will lose 2 electrons. A would be the right answer. And last one, here we go. Question 4. When a bromine atom forms an anion, it does so by losing 2 electrons, gaining 2 electrons, losing 1 electron, or gaining 1 electron. Pause the video, try and answer it, and I'll give the answer when we come back. Okay, we're back. And bromine atom, well, if you hopefully found bromine, it's a halogen. It's all the way over there next to the noble gases. And so bromine is going to gain 1 electron to look like a noble gas, and that's what it does when it forms an anion, because anions are negative. So, if you have any questions on those, be sure to ask me, and I'll be happy to answer them for you. And we'll see you next time.